So you probably saw some of these in like an algebra class where you were adding. They were finite sums, usually when you see them before, but now we're gonna take infinite sums. So I start off with a first term A, and then in a geometric series, the way you get each successive term is you multiply by a fixed number. So I'm gonna call that number R, A times R, plus A times R squared, so multiply by R, A times R cubed. So in general, the nth term is going to be A times R n minus 1. And you could write this as a sum with the formula AR to the n minus 1. And here I'm only considering A not equal to 0. Because if A was 0, it would be pretty boring. 0 times any number is 0, so it's a list of zeros. Okay? So I am going to tell you that you've actually already seen, or maybe I'll say we've already seen, a geometric series. Flip back to the examples I did at the beginning, 1 and 2. Example 2, the one with the fractions, 1/2, 1/4, 1/8. That's a geometric series. What am I going to multiply by to get the next term? If I take 1/2, what do I multiply by to get 1/4? A 2 in the denominator, right? So I multiply by 1/2 to get 1/4. I take 1/4 and multiply by a half again to get an eighth. That's a geometric series. So you've actually already seen them. I just didn't tell you that you saw what they were. Okay? Okay. So, see example 2. Okay, and I want to decide, what I really want to know is I have a geometric series. When am I going to know if it converges and diverges? And if it converges, I want a formula for the sum. So I have no idea right now. Let's say I plug in R equals 1 is the easiest thing for us to plug in, okay, for R. And let's see what kind of series am I getting if I plug in R equals 1. If R equals 1. So my first term is A. What's my second term going to be? A times R. A. Next term? A times 1. A. Right? I'm just adding A to itself a bunch of times, because I'm multiplying by 1 to get my next number, by 1 to get my next number. So it looks like I can come up with a really nice formula for the partial sums in this case. S sub n, it's going to be A plus A plus A, and I have n of them. You have n numbers here, n A's. So the formula is going to be n times A. If you add a number to itself n times, it's n times A. Okay? And now we can look at this limit. Again, we're assuming A is not 0 here. I can pull A is just a constant, so you can pull that out of the limit if you want. So what's that limit going to be? Infinity. Well, okay, infinity times A. And remember, A is not 0, so it's either positive or negative. So in the end, my answer is either positive infinity or negative infinity, depending upon the value of A. Okay? So this here is either infinity or negative infinity. And the sign, again, depends on A. If A is positive or if A is negative. Okay? So it doesn't really matter though. I took the limit, either I get infinity or negative infinity. Does that tell me, what does it tell me? Does my series converge or diverge? It diverges. In either case, it diverges. I needed to get a finite number back and I never do. So I now know that this limit is, I'm not gonna write this. The limit is either infinity or negative infinity, which now tells me the series diverges. So when R is 1, when R is 1, the series diverges. That's what we just learned. Okay? All right. What if it's, yeah.
Do we need to like explicitly say that? Like if you're given a problem, do we need to say the series diverges when R equals 1?
You'll have, so in your case, if you are given a series, it'll have some kind of value for R already predetermined.
Good.
So if I give you a geometric series, it's gonna have numbers in it, and you're gonna have a specific value of R. So what we're trying to do is we're trying to make some kind of conclusion about if we know the value of R, we should be able to decide if it converges or diverges. And so that's what we're trying to figure out right now so that you can use it on problems. Does that make sense?
Right. Yeah.
Like in the example 2 that we did earlier, we knew R was 1/2. So we're trying to come up with a formula that says, or some kind of statement that says if R is this number, I know it converges. Any other number, it diverges.